Alright, so today we're looking at finding function values using the fundamental theorem of calculus. That's what we want to do today. So what do we mean by a function value? Y value. We're looking for a y value. So that's what we're doing today, is finding y values using the fundamental theorem of calculus. So there are kind of two different ways that you can get to this answer. I'm going to show you the first way, but that's not the way we eventually want to do it. We want to do it the second way, which is using the fundamental theorem of calculus. But I'm going to show you both, and then we want to use the fundamental theorem of calculus to do it. So I have given dy dx equals 3x squared plus 4x minus 5 with the initial condition that y of 2 equals -1, and we want to find y of 3. So method 1 says integrate and use your initial condition to find c. So if I integrate this thing, 3x squared turns into
X cubed.
4x turns into
2x squared.
2x squared. And the 5 turns into 5x. Don't forget about the plus c. Now what do I want to do? Plug in to find c. So I plug -1 in for y. I plug 2 in for x. So that is 8 plus 8 minus 10 plus c. So 8 plus 8 is 16. 16 minus 10 gives me 6. When I move the 6 over, that tells me that c is equal to 7. -7. So that means y equals x cubed plus 2x squared minus 5x minus 7. Now, this part where it says particular solution, you have found a particular solution once you've integrated and figured out what c is. So if something ever tells you to find a particular solution, that means you integrate and figure out what c is. But we don't want to stop there. On this problem, we want to figure out what y of 3 is. And what do I do to figure out what y of 3 is? Plug 3 in for x. So that's going to give me 27 plus 18. And then 3, so -15. Minus 7. So 27 and 18, that's going to give me 45, and -15 and -7 gives me -22, so we end up with 23. So that is one approach to figure out the y value, given, what type of equation is that again, that we started with? The dy dx equals 3x squared plus 4x minus 5? What type of equation is that called? Differential equation. Very good, Brady. Alright, so we can integrate the differential equation, use the initial condition to find c, and then plug in to find our y value. That's one method, but that's not the method we want to use. We want to use the fundamental theorem of calculus. It is not going to be hard.
It's going to be easier.
And this is the way you need to use it. The AP people like the fundamental theorem of calculus. This is what we need to use, and there are some problems where you have to use it. You have no choice. So, yes.
Why is there like a shadow of numbers and letters on there? It's like somebody wrote this.
Up here?
Yeah.
Okay.
It's like,
Yeah, I can see it. Okay. Alright, so use the fundamental theorem of calculus, which says the integral from a to b of f prime of x dx equals f of b minus f of a. So how can we apply this to what we're trying to find? Okay, so let's look at this information and see if we can plug that in somewhere. Where do you think y of 2 and y of 3 go?
F of B.
F of b and f of a. So which one's which?
-1.
I would have y of 3 minus y of 2. So if that's correct, what goes in on this side?
F prime of x is
2 to 3, and then my derivative is 3x squared plus 4x minus 5 dx. What is it I'm trying to solve for?
y of 3.
Y of 3. So what do I do to get y of 3 by itself?
And
Add y of 2 over. So I have y of 2 plus the integral from 2 to 3 of 3x squared plus 4x minus 5 dx, and that is equal to y of 3. And if I solve that, that's going to give me y of 3. Now, when we get comfortable with this, we're going to be able to go straight to this. We don't have to do that part. Okay? After we do this problem, we should go straight to this to get our answer. So it's going to be a little bit shorter next time we go. When I'm explaining it, it's going to seem like this is longer than the first method, but this is the best method to use. Now, somebody explain to me why this makes sense. Why does it make sense that y of 3 is equal to y of 2 plus the integral from 2 to 3 of that function?
Because what that is what we found earlier. Right? Solution.
What does that represent? What does that represent?
Change the function above.
And what is the function above? Y. Y is the function above. So this definite integral represents the change in what? The change in y from where to where? From 2 to 3. So, if I know where I'm at 2, and I know what the change is from 2 to 3, what do I need to do to be able to figure out what y of 3 is?
Add
Add them. So that's why it makes sense. I've got my starting y value plus the change in y, and that gives me the y I'm looking for. That's why it works. Because I have the starting y value plus the integral. So if we're looking for y values, and we want to use the fundamental theorem of calculus, we need the initial y value plus the integral, and that gets it done. Now I want you to notice, you need to notice our limits. What limit is on the bottom? I know, but what is 2 in this problem? How do I know which limit comes first? Is what I'm asking. Whichever x value that goes with the y value you've got. So since they gave me this, that means this right here has to be my lower limit. Okay? And whatever I'm looking for, that x value has to be my upper limit. Okay? So we have our starting y value plus the integral from our lower limit to the upper limit. So now, let's use this, and we should get the same answer when we do it correctly. So I'm interested in finding y of 3. I'm interested in finding y of 3, and that's going to equal my starting y value. What's my starting y value? -1 plus the integral from 2 to 3 of 3x squared plus 4x minus 5 dx. And that gives me what I'm looking for. So the -1 stays there. Now I'm ready to integrate. So I should get the same thing. I'm going to get x cubed plus 2x squared minus 5x. And we're evaluating that from 2 to 3. So I've got -1 plus, which one do I plug in first, 3 or the 2?
3.
The 3, so that's going to give me 27 plus 18 minus 15. And then minus, I plug in 2, that's going to give me 8 plus 8 minus 10.
It's definitely longer.
You think it is right now, it's not, I promise you. This is the way to do it. It just seems like that because we have to do a lot of explanation. But you're going to disagree with me anyways, because that's the way you do it. Alright, so I've got the -1. I've got the -1. This right here is the 45 minus 15, which gives me 30. And this over here is 16 minus 10, which is 6. And we end up with a function value of 23, which matches the original function value. Okay? So, let's look at this next problem. And this next problem is why you need to use the fundamental theorem of calculus. Okay? It says sometimes there is no antiderivative, So we must use method 2 in our graphing calculator. So if I can't integrate it, then I've got to use the fundamental theorem of calculus. So I want somebody in here to set it up for me to be able to find f of 2. What is it going to look like if I want to find f of 2?
F or so -5.
Negative 5
Plus.
plus, Brock, keep me going, integral from where to where?
1, 2.
1 to 2 of sine of x squared dx. That gives me the function value of 2.
How'd you say you know which one's A and B?
Okay, how do I know which one goes on the bottom?
The one it gives you.
It's the x value of the one they gave me. So the x value that has a y value, that's the one that's on the bottom. The x value of what you're trying to find goes on top.
Do they always give you the smallest one? Or
No.
just a coincidence?
We will get to that on part 2 of this problem. So now we're ready for our calculator. We need to make sure we're in the correct mode. What mode do we need to be in? Radians. In calculus, we need to be in radians. So make sure it's in radians and make sure you hit make default. And then we want to do a new document. And we want to add a calculator. So then I just need to punch it in just like it's written. So I want -5 plus the integral. How do I get the integral?
Control.
No.
D.
Shift
Plus.
plus.
Nice.
Shift plus. It went from 1 to 2. So I'm going from 1 to 2. And it was sine of x squared dx. And I get negative 4.505. So we have our starting y value, and what does my definite integral represent? The change. So it's starting y value plus your change in y, and that gets you to the new y value. Now let's look at part 2. It says, what if you had been given f of 2 and were asked to find f of 1? So let's say they had given me that f of 2 was equal to negative 4.505, and this time we wanted to find f of 1. So f of 1 is what I'm looking for. Justice, set that up for me to find f of 1.
1 is -4.5. Would you subtract or add?
You'd still add.
Still add, okay. Plus the integral sign. 1 on top, 2 on bottom.
2 on the bottom, so from 2 to 1 of sine
Squared dx.
of x squared dx. So when I punch this in, what should I get as an answer?
5, negative
-5.
5.
I should get -5 as an answer. So it was, I'm gonna go up and get my actual answer so I can get -5. So I'm gonna get that actual answer. I'm gonna go plus my integral, so shift plus. We're going from 2 to 1 of that same function, sine of x squared. And when I press enter, I should get -5 as my answer. I press enter, there's -5. So it does not matter. It does not matter which way you're going here. Okay, you always put it in. The x value of the y value you know has to come first. The x value of the y value you're trying to get needs to be on top. Now, what if I was trying to do this one by hand? What would I want to do to this if I was doing it by hand?
Change the sign.
I would want to change the sign out front and make it go from 1 to 2. Okay, so if you're doing it by hand, change the order of this and change your sign out front. Okay, but if you're doing it with the calculator, it doesn't matter. Just punch it in as you see there. All right, move to the back. Alright, now we're going to do the same thing, except this time we're going to have a graph to help us. Whenever you're doing these types of problems, I want you to ignore the graph to begin with. The graph confuses people for some reason. So get the problem set up before you look at the graph. So right now, I'm ignoring that graph over there. It says the graph of f prime consists of two line segments and so on. It says given the fact that f of negative 2 equals 5, find f of 0. So I want to find f of 0.
How does
Five.
f of 2 equal negative 5? It's correct.
What is that graph of? That's why you're not supposed to be looking at the graph right now, because you're confusing yourself already.
It
Oh,
equals
I didn't
5
see
plus
that.
the integral from f from x dx.
5 plus the integral from where to where?
From 0
Negative
to 2.
Negative 2 to 0 of f prime of x. Any issues with that? Alright, let's set up the next one. F of 2. What's f of 2 going to be? 5 plus the integral from negative 2 to 2 of f prime of x dx. And the last one is going to be 5 plus the integral from negative 2 to 6 of f prime of x dx. Once you have them set up, then you can proceed to the graph. Because what have I taught you that each one of these represents? The change in the function above, but also, if I'm looking at a graph, the area under the curve. So see, if I have a graph, and I'm wanting to evaluate this, I'm looking for area under the curve. And in this case, the area between negative 2 and 0. So I'm looking for the area of that piece right there. So what is the area of that piece?
So wait,
The area of that, the base is 2, the height is 4, so 2 times 4 is 8, divide 4, so 5 plus 4 tells me that this is equal to 9.
The area under the curve is the same as the change in f.
The definite integral, have I not told you guys what the two things the definite integral represents? Have we not talked about this over and over again?
So the change above.
The change in the function above, or the area under the curve of the function you're dealing with.
So not both at the same time.
They do represent both at the same time.
So it's the change in f too.
It is also the change in f.
Okay.
So that means my original y value is 5. The change in the y value is 4. I put those two together, that gives me my new value of 9. So, the next one, I'm going from negative 2 to 2. So I'm going from negative 2 to 2. So what do I end up with there?
Double.
8. So 8 plus 5 gives me 13. Then, I'm going all the way to 6. So now I'm dealing with this area down there. What do I have to do with that area?
You have to add
The triangle plus the symmetry.
Alright, so I already know that this piece, I know that piece is 8. How do I get the area of that piece?
Pi r squared.
Pi r squared divided by 2. So what's my radius?
2.
2. So 2 squared is,
4.
so we're dealing with 4 pi and I divide by 2. It's 2 pi. But it needs to be what? Negative. So I'm looking at 5 plus 8, which is 13, and 13 minus 2 pi gives me what I'm looking for. Next one. And again, we're ignoring the graph to begin with. So, Shanine, set it up for me to find f of 0. F of 0, Shanine. Set it up for me to find f of 0. Ignore the graph.
5 plus 3 to 0
Very good. All right, Chelsea, set it up to find f of 7.
5 plus the integral of 3 to 7 f prime of x dx.
Very good. Kaylee, set it up for f of 9.
5 plus the integral from 3 to 9 of x dx.
Very nice. Any questions on those 3 setups?
Should we change the first one to 5 minus 0 to 3?
All right, since we're doing it by hand and not using a calculator, Logan recommends changing this from 0 to 3 of f prime of x dx. I'm fine with that. So, what is the integral from 0 to 3 of f prime of x dx? What is that amount?
4.
4. So that means f of 0 is equal to 1. What's my area from 3 to 7? 9, but it needs to be. So that means f of 7 equals -4. Alright, so now we're going from 3 to 9. So I already know I've got -9 there, and I have a +2 there. So what am I going to end up with on f of 9? -2 is correct. Now, I want you to notice something about each one of these x values that was chosen. What do you notice about those 4 x values?
It's where it crosses the x-axis.
That is where it touches the x-axis on my derivative. So notice that each one of these points gives me that. Because when you do your own assignment, they're not going to tell you which values to find. You're going to have to know which values to find. And you're going to want to find the values where your derivative touches the x-axis. Now, I want to get to sketch the graph of f. So I've already got 4 points I know about f. So I'm going to plot those 4 points. So I have f of 3 is 5. 1, 2, 3, 4, 5. So f of 3 is 5. I have f of 0 is 1. I have f of 7 is -4. There's that. And I have f of 9 is -2. Which is right there. What other information does the graph of the derivative tell me that's going to help me give a
Concavity.
better graph? All right, Harrison says concavity. So talk to me about concavity, Harrison.
When it's increasing, it's concave up, decreasing, concave down.
So what does this graph start out doing?
Concave up.
Increasing, so that means it needs to be concave up until what x value?
One and a half.
1.5. So what I like to do is, I have no idea where that point is on here. Okay? What you want to do is, I like to go to 1.5, and then I like to find out where that would meet up. So it would meet up approximately somewhere in there. Okay? And I know between those first 2 points, between the blue point and that first red point, what does my graph need to look like?
U.
It needs to be a concave up. So when I connect these two, I want to show that it's concave up. It's got to be concave up, and it's got to be increasing. Why do I know it's got to be increasing? Because my derivative is positive. All right, so I am concave up until that point. Then what does my function do? It's concave down until where? 5. So what I'm going to do is I'm going to go find 5, and then I'm going to go about in the middle, so it looks like about 5, 0 is where I want to be. Okay, so between those 2 red dots, I know I need to be what type of concavity? Concave down. So I'm going to connect those 2 with concave down. So there's that. Then I change back to Why do I change the concave up?
Increasing.
My derivative is increasing. Where does it stop being increasing? At 8. So at 8. So I'm going to go to 8. Here's 8. I'm going to go and line it up. There it is. So that means from here to here, it's got to be concave up. And then that last little piece has to be concave down. That last little piece needs to be concave down. So if you're going to sketch a graph of f by looking at f prime, you need to find the function values. How do you know which x values to use?
Where across the
Where it crosses the x-axis. After you find your function values, then you want to find your points of inflection. Notice, where do each of my points of inflection happen? At the maximum or the minimum of my derivative. Okay, that's not a coincidence. That's where points of inflection happen if you're looking at the derivative. Okay, and then match those points up and give me the correct concavity. All right, one last problem. All right, it says a temperature or a pizza with temperature of 95 degrees Celsius is put into a 25 degrees Celsius room when T equals 0. These pizza's temperature is decreasing at a rate of R of T equals 6 times e to the negative 0.1 T degrees Celsius per minute. Estimate the pizza's temperature when T equals 5 minutes. So what does it want me to find?
This temperature.
The temperature when?
T equals 5.
So it wants me to find my temperature at 5. What do I know?
The rate.
I know my rate is R of T equals 6 e to the negative 0.1 T. What else do I know?
Pizza temperature at 0.
I know the temperature at 0 is 95 degrees. So I've got everything I need to find the temperature at 5. So Brock, set it up for me to find the temperature at 5. 95 plus 0 to 5 of so 6e to the negative 0.1 t dt. Punch that in your calculator.
How do we know that's the derivative or not supposed to be derivative?
Okay, how do I know I'm dealing with a derivative on here? What in this problem told me that function right there is a derivative?
Rate.
Rate. Anytime you hear the word rate, that tells you you're dealing with a derivative. So that's why I knew it had to be inside. Okay, because if I'm dealing with degrees Celsius per minute and I integrate that, what do I get? I get degrees Celsius. And that's what I'm looking for. I'm looking for degrees Celsius. So let's punch that in and see what we get. So 95 plus, shift plus, we're going from 0 to 5 of 6. Make sure you use this E button on the left. A couple people last hour were using the E at the bottom. You got to use this E button on the left. I need a negative 0.1. I'm going to use X instead of T. You can use T if you want.
Yeah.
Press enter. Do we like that answer? 118.608 degrees Celsius. No.
No, that's,
It got hotter.
It got hotter.
is that Fahrenheit?
It's a decreasing rate, so what needs to change?
Is it 95 minus?
You could change it to 95 minus, or what else could I do?
0 to 5?
I can put a negative on that 6. That way my rate is decreasing. So either way, same thing. That's why I said or. So I can go in here and change this to a negative in front of that and press enter. Then we get an answer that we like. So 71.391. So always make sure your answer is reasonable. It should have been very obvious that 118 was not reasonable because our pizza should not be getting hotter. It should be cooling off. So if you're gonna use the fundamental theorem of calculus to find function values, how do you set that up? How do you set it up to use? How do you use the fundamental theorem of calculus to find function values? How do you set it up?
F of A.
I need my just in general. I don't want specifics. What do I start with?
Starting with
My starting y value plus the integral. That gives me the function value I'm looking for.